What about this? Left hand side, there is no grouping factor, nothing. Then count the social security number and average salary of employee. What does that mean? If there is nothing on left hand side, no grouping factor, we are going to consider entire employee relation as grouping factor, which means we have only one group. So this count means total number of employees, and this average means average of entire employee's salary. So nothing on left hand side means only one group. That is the reason output how many tuples? Only one tuple is returned. So which means how many employees? 8. So average salary of entire employee is 35K roughly. So more example will be here. So maximum salary. What is the maximum salary of entire employee? Nothing left. Minimum, summary, and this one is the for each department social security number and salary. It's a count number of employees. Okay. This is very useful, but be careful when you are using aggregate function in SQL. Why? It looks very convenient. However, you should be careful to use such an aggregate function.
To avoid the null values.
Avoid what?
Null values.
Null value? Yeah, that may cause a problem. The bigger problem is performance. So how can you find the maximum? How can you find the minimum? You need to do what?
Go all through the relation.
Sorting the data. You need to sort, not go over. You need to sorting the data. It's much more expensive. Okay? So if you intentionally use a lot of aggregate function, your query will be very slow, because before your DBMS return the data, it compute a lot of things. So think about that we have the 1 terabyte size table. We are going to sort 1 terabyte size table. It takes long time. Okay? No matter how fast the sorting algorithm is used, it takes up time. So you should be careful.
But what about average and sum? Does it?
But anyway, you need to go over all of the data. Yes. So that is the reason. Then recursive closure. It's the same question as the previous one. Sometimes there is a requirement. I'd like to access, for example, so in employee, as you may know, we have employee, SSN, and super SSN. This is the foreign key. Can you remember that? This is the recursive, the relationship. Okay? So, for example, 111 is supervised by 001, which means 001 is the supervisor of 111. It may have many, because it's one to many. 112, 113. Also, 111 will be supervisor of 121. So we have 121, 122, 123. It may have 124, 125, 126. Also, 121 will be supervisor of 131, 132. Kind of tree structure. Is there any convenient way to access this kind of tree structure? Actually, the first version of it, which is called the SQL Standard 2, SQL 2, does not support, do not support such a hierarchy. Why? Because relational database model actually deal with tuple by tuple. it's very hard to access one tuple all of them. One tuple all of them. No, it's not easy. So, however, there are a lot of requests from user. We need to access conveniently such a hierarchical structure. So, new standard of the SQL. We will learn the history of the SQL later after midterm exam and spring break. At the time, you will learn new SQL standard include recursive closure operation. So that supports such a recursive call. Like for example, supervised by Borg is 2 and supervised by Borg's this one. This is the supervised and this. And this one is also supervising this. Hierarchical structure, tree structure can be written by this, the recursive closure operation. But in our class, we are not going to include this recursive closure operation. However, you probably should in mind when you are doing the real project, sometimes you can use such a recursive closure operation. The next, we did the most of the thing except some special join operation. So let's say we have relation R, C1, C2, S, B and B2. So 1, 2, 9. A, B, 9. 1, 2, 3. And 1, 2, 3. B, C, 9. Okay? So this is a key, this is a key. Most of the case, when we are joining two relations, we are going to use foreign key relationship. Most of the case. Sometimes you can join the two attributes. They are not related. In other words, there is no foreign key constraint, but you can join. But at least their type should be the same. For example, in this case, I'm going to join C2 and D2 attribute. They are not actually foreign key constraints. Okay? However, we are going to join two attributes because they have the same data type. So for example, what is a join? So we can first do the Cartesian product. Cartesian product C1, C2, D2, D1. How many tuples total? So 3 by 3, it will be 9. So 1, 2, 3, 1, A, B, 9. No, A. Then 1, B, 1, C, 2, 9, 3. Okay? Similarly, we can do 2, B, B, C, 9. 1, 2, 3. 3, 9. And B, C, 9. 1, 2, 2. So 1, A, 1, A. 2, B, 2, 3, 3, 9, 9. This is the Cartesian product of R and S, right? So we have a total 9. Then we are going to join R and S, join with condition what? C2 is equal to D2. That means AB, AC, A9, BB, yes. This is the same. And BC, B9. Null B, null C. This is AB. This is null. Null. Do I need to include this one? Null is equal to null. True or false? False. None cannot be compared.
Cannot be compared.
None is not none. Okay? None is none. However, none means it's a not existing. You cannot compare not existing and non-existing. Who knows? What is that? Nobody knows. So we cannot compare. So only this one will be returned. So output of this is this row. That is a join operation. However, sometimes I want all the data of R. That means one of this, one of this, one of this. If the data is matched, okay, that means it's a C1, C2. 1, 2, 3, A, B, none. In this case, if the data is matched, D2, D1, it's a D1 return. Otherwise, if not matched, we can just pad null data. Null, null, null. That's what you are asking, right? In case of the matched, we return the data. That is join operation. But sometimes I want to hold the data of R, left-hand side. So put left-hand side. What if there's no matched data on right-hand side? Just padding the null data. This is called left outer join. We are going to open to left. So symbol is like this. The left outer join. Very, very useful thing. What if right outer join? Since we have left outer join, what about right outer join? Which means we are going to keep all the data of right hand side. 1, 2, so BC, none, 1, 2, 3. So this match it, you can put non-match, none, 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 none. This is right outer join. Then somebody may be curious. Is there any left and right outer join? Which means if both of them are matched, yes, return. Otherwise, not matched. 1A, null, null. 3 null, 3 null, null, null. In this case, this is the full outer join. Left outer join plus right outer join. It's a full outer join. Because the join itself is very strict. Only the tuples that satisfy with the condition will be returned. That means in case of the null, it will not be returned. So why don't we allow such a non-matched, but we need to keep the left-hand side or right-hand side or both sides. That is called the outer join. So for example here,
can you repeat the last one, which is both?
yes, just using this. First, I'd like to retrieve all the employee and their manager name, if we exist. If not exist, just put the none. Then you can see who has the manager, who has not, right? So left-hand side will be full of employee. Right-hand side, the matched one, research, administration, and headquarters will be joined. The other will be null pad because we keep all the data left-hand side. If you allow the right-hand side, all departments will be exist, right? Then, if there is a manager, you read first name, middle name, initial, last name. Sometimes, if there is no manager, but there exists department, at that time you can put null plus research. Both this one and right join, you can combine. That is full outer join. Okay, that include the matched one, joined one, and left-hand side only plus right-hand side only. That is full outer join. Okay, in real life lesson, most of DBMS support left outer join, right outer join, full outer join. Among them, either left or right outer join are frequently used. For example, I'd like to make a report of employee. That shows the manager information. So at the time, if we omit this one, we don't know who are non-manager. Okay?
The manager. Manager.
So it shows only the manager information. What about non-manager? I'd like to select a new manager. Among non-manager, at the time you need to prepare another report. At this time, you can put all together in this report. That is outer join. Okay. So, for example, this is the example of relational expression. Question is, retrieve the name and address of all employees who work for the research department. Probably in your page 1, you list of the realistic query. In English, that should be the same as this one, right? So you already have the query. Then this time, in page 3, you need to convert your realistic query into relational algebra. At the time, first, you'd better identify which relation are needed. For example, to retrieve the name and address of employee, you need to use what? Employee. Also, who works for the research department? Where can you get the research department information? Department, can you find the RE, SE, AICH from employee or others? No, only department can provide such a thing. Then, there are many different ways actually to access such a data. First, you can access department first. Then find which one is the research department. Then take department number. Then move to the employees. Then find the employees whose department number is 5 or 4. Right? Then we can get the name and address of all employees. Another way is first going to the employee room first. Then collect all the employee information. Okay? Then at that time, we need only name and address. Okay? Take out all the other useless information. Name and address, also department number. Then moving to the department room, department relation. Then check which one is the research. So take out. Research is the number 5 or number 4. Take out all the other employees, then leave. Match it one. That is another way. So there are many different ways. So for example, in this case, I'd like to access department first. DPT, whose D name equal to research. Select. This is the department, research department information. Then employee. Join to relation. Join condition is D N is equal to T number. Right? What is the D number? It's a research department D number. Then the last thing is we need only name and address. This is the final answer of relational algebra expression. So sometimes you can separate the relational expression operation by operation. This is the same as this one. there are a bunch of different ways. Also, somebody may access employee first, then join with the department. Then D number is equal to DN. Select D name is research. Then take name and address. That's doable. In terms of output, both any of them are safe. However, in terms of performance, it's different. Sometimes this one may be the fastest one. Sometimes this one may be the fastest one. Sometimes this one may be the fastest one. Who decides? Query optimizer in your DBMS system will decide which one is the fastest one. Based on what? Statistical information about your table. Each table. Sometimes it may have the 10 millions of data. Sometimes 10 millions of data. This one is just one. Which one is better? You'd better have the one, or you'd better have the one right hand side. It depends. Okay? So query optimizer determining. That caused a problem in your exam. So in your exam, even though there is only one question, answer will be various. So I'm going to decide whether you are correct or not based on output. I'm not going to consider any performance issues in this database design, but in terms of output, if that is correct, yes. Or sometimes I'm going to specify the answer using only one relational expression. Okay? So then at that time you can combine into one. Next question, last one. Retrieve the names of employees who have no dependent. Can you understand the meaning of the query question? There are two types of employees. One, having dependent. Another one, no dependent. So I need to retrieve no dependent. How can you get it? If we can list the employee having dependent with dependent, that's it. We can subtract, take out. Can you understand? From all employee, we can take out the employee with the dependent. Then remainder will be employee with non-dependent. For example, first get the social security number of employee, all employee. Then get the ESSN from dependent. That means employee with dependent. This one. That's it. We can subtract from all employee by the employee with dependent. The remainder is the employee non-dependent. But we need to access the name of the employee. So using social security number, we can do natural join or any join operation. Or you can include the name in here. Okay, you can specify the name. You can retrieve the social security number plus name. Social security number plus name. Then subtract. You can get the name. Okay, anyone can be doable. So this is the relational operation. We will see more example in the after spring break. Okay. Then one more thing. These are the relational operation. The next thing we will briefly go over the relational calculus. Relational calculus is like that. T bar condition T. Are you familiar with this format? Yes, you used a lot in your set theory, elementary class, or instead of 1, 2, 3, 4, x bar x bigger than 0, x is integer, natural number. Can you remember that? Exactly same format. So, what is the difference between this one and relational algebra? For example, here, first name, last name, employee, and salary is bigger than 50K. What's the difference? It shows only condition. So relational calculus focus on output condition. it doesn't show how to access the data. However, relational algebra, first department, then employee, then join and project. We can understand how the data are accessed step by step. So query optimizer used a lot for relational algebra. Using query tree, we can convert easily query relational algebra into query tree. Then query optimizer decide project, then department join and return the project. Something like that. You don't have to worry about this. We will discuss in advanced database course, which will not be covered in the database design. So relational calculus focus on only condition, output, data itself. In other words, that will be almost the same as the where condition in select from where clauses in SQL standard. We will see the SQL standard after spring break. At that time, we will see how relational algebra and relational calculus are used in SQL database language. Okay, so next class, we are going to have the interim presentation. I don't think, which one is better, this room or 163? For morning class, we are using the next room, so it's okay. But the afternoon class, this room may not be convenient. So I reserved the room already, so if you guys want, we can use the 163 for your presentation. Do you want to use that?
This one is fun.
This one is fun. The problem is, it's a little bit hot. Definitely. So you want to keep this? Okay, so we are going to meet in this group. You don't have to go to the 163. Regarding to the undergraduate, so I already informed to the Prof. So you can decide either morning or afternoon, but let me know before the class, at least by the Monday. Okay? You don't have to present all of 3. Yeah, only one is in. Okay. Any others? Do not prepare very long details presented. We do not have a time, less than 10 minutes. And if you are going to use my laptop, email me to save your file. Otherwise, you can use your laptop. Right now, most of the laptop is working well with the projector, except the HP computer. So if you have the HP, please check before you start the presentation. And